Okay, welcome back students. We're doing question 10 from the 2022 paper, and we have a picture. So we'll first of all always look at the graph before you would read anything, if you need to read anything. So it looks like some sort of a sports competition where there's a kayaking, cycling and running exercise. Okay, let's start reading. Ali and John took part in a triathlon. Okay, that's what it is, triathlon, three sports. In the triathlon they had to complete a 5-kilometer kayak. Let's just check if that information is on the diagram. It is 5 kilometers. Okay. Very unusual though that the time is going this way. Time is almost always going this way. So they've kind of reversed things around, but it's still a function because it's continued, except for here it's not a function here. We'll figure out what happened here later. Because a graph of a function can never go straight up and it can never go back on itself. It must keep moving forward. And the diagram below was drawn after both of them had finished the race. So let's check it out. 25 kilometers. Yeah, so they've traveled 30 kilometers in total here, and then another 10. Great. Diagram below was drawn after both of them had finished the race. It shows how many minutes more than John or less than John it took Ali to travel. Okay, so he's being measured against John, and this is Ali's graph compared to John, relative to John, to travel d kilometers. So yeah, the kilometers are out here in the triathlon. So up to 40, fine. For example, the point A shows that it took Ali 1 minute more than John. The point A says it took him 1 minute more than John to reach this point. So that makes John's graph the straight across graph here, I think. In total it took Ali 1 minute less than John to finish. Okay, so the back line is Ali's line, and this is time more than John. Positive time, and this is negative time. Okay, did Ali finish? So that's it, we kind of get it, and we can go back and gather information, take information from this as we need it. Sometimes we're having an input value and getting an output value, and sometimes we're having an output value and having input, and here we could have two, at what times or at what distances was he 1.5 minutes ahead, like that, and so on. So we'll just roll with the punches, roll with the questions, and see where it takes us. Okay, so did Ali finish the kayak section ahead of John? No, because he was slower than John by 2 minutes. And so your answer can be Ali finished the kayak section ahead of John, behind John, at the same time as John. So we'll go with behind John. And you're not asked for a reason or anything? Strange. Ali had to stop briefly during the triathlon. John did not stop. I'm just reading again. Is this? I should have written on this. This is Ali, isn't it? We're comparing to John. Yeah, this is Ali. Okay. Ali had to stop briefly during the triathlon. John did not stop. State what distance Ali had travelled when he stopped, and for how long was he stopped. So at this point here he wasn't travelling forward at all. So the distance he had travelled when he stopped was 25 meters. That's the input value. 25 kilometers. And the length of time Ali was stopped for is what's the size of this interval. So we can count them here, 1, 2, 3. So I'll be very careful there. There's 3 ticks but 4 intervals. 1 interval, 2 sorry, there's 3 intervals. 1 interval, 2 intervals, 3 intervals. And 3 intervals over here is worth 1.5 minutes. Is it 1.5 minutes? Yeah, how many minutes? So 1.5 minutes. Is it M for minutes? Well, they've spelled it out there. Minutes. That's why we'll do the same. What was happening John and Ali at the point marked B on the diagram? Ali was overtaking John because Ali had been behind here. So what was happening John and Ali? Ali was overtaking John, but at that moment in time, instantaneously, they were level. At point B. They were both, if you took a photo of it, they were both at the same distance travelling alongside each other. The table below shows the time it took John to complete each of the 3 sections in the triathlon. So we're getting extra information here. We're finding out how long it took John, and from that we'll be able to see how long it took Ali. Maybe that's what they're going to ask us, as well as his total time for the triathlon. Using the diagram, fill in the 4 missing values for Ali. So at the end of the kayak, we know John was 32 minutes and he was 2 minutes slower, so I think it took him 34 minutes. I hope I'm right on that one. Now for the cycling, and when did the cycling end? It ended here. So after this 38 minutes, we can see that Ali is 1 minute ahead, so 37. Okay, after the run, which is here, he is also 1 minute ahead. Okay, I wasn't, yeah, and this isn't absolute time, this is the time for the run was 35, the time for the cycle, but again I can add them all up. Now what am I expecting to get? I'm expecting to be a minute shorter than this, so I hope I get 105 when I add them, and I'm not going to, I'm looking at it here, maybe 104, but I shouldn't get 104, in which case I might have a mistake. So if it's time for me to go back, I have time to go back and revise, so let's just see where we're at now. So I may well have made a mistake, especially with the scaling factor here, 2 to 1. It's quite possible I made a mistake, and always beware in checking yourself. So I don't. When you started level, it took John 32 minutes. It took Ali 2 minutes longer. It took more than John, 2 minutes more than John. So this is correct. Maybe I have to take into account where he was relative before I go do with this. So he was 2 minutes behind, and he ended up 1 minute in front. So he has a 3 minute gain. So 3 away from 38 is 35. Now you're seeing problem solving, the real thing. Okay, you're seeing that, and I've often said to you, don't go into the paper thinking you know it all, what's in there. Go into the paper thinking you're going to figure it out all in there, and I hope that's what I'm doing now. And it's my check there and the fact that I predicted what I should get and it wasn't what I wanted means I'm here now doing this. Okay, now from this point there is no difference between them, which makes me think this should come in at 36, that they both took the same amount of time, they just had that constant gap between them. Okay, now we'll add up again, and I think I'm looking much better now. 34 plus 35 plus 36 is 105, and he's a minute in front. Okay, so that's a true example of the process occurring in the exam, and I had some issues with checking and I worked it out. John and Ali also ran a 400 meter race. Sorry, I didn't show you the grading, and because it's stretching out to be quite, I would call this one of the most difficult questions we've done. So before we get down to the actual answers, let's look at the grading matrix here. So for question 10, it's worth an awful lot of marks. 10, 10, 20, and 5. So 10 for A, 10 for B, hang on, no, wrong. 10 for A and B together collectively, 10 for C, 20 for this. So it was, unlike normally a very difficult bit, questions can be worth very little because the way they're bending the marking scheme. In this case it is worth quite a bit, and then the last bit is worth 5. Okay, let's keep going, we're nearly there. John and Ali ran a 400 meter race. John's average speed for the 400 meter race was 7.8 meters per second. Okay, so let's write, some of you might remember this triangle, I'm not a fan. So the distance equals speed by time. Speed is distance over time. What you really want to be doing, because you get no, this is not an equation, so you will never get any marks for this. You're far better off writing out 3 possible equations. That one, this one, and D equals ST. Okay, so speed is proportional to distance and inversely proportional to time. Time is proportional to distance and inversely proportional to speed. And distance is directly and jointly proportional. Directly and jointly proportional to speed and time. Make the speed, double the speed, you double your distance, double the time, you double your distance. Now we only need one of them, but I just want you learning as much as you can, so that's why we did all that, and I'd recommend you continue along with that. Okay, another thing you can say here is speed is inversely proportional to time, in that as the time goes up, the speed goes down. And time is inversely proportional to speed. As the speed goes up, the time goes down. Anyway, so work out Ali's average speed for the 400 meters. So if we're working out his average speed, these are averages, so we're working out his speed. So we're using this formula. So how far did he travel? We're not using that formula. We're using this formula. Hang on, work out Ali's average speed. Oh, hold on. Okay, sorry, I haven't read the question enough. John's average speed was this. It took Ali 2 seconds more than John to run the 400 meters. Okay, so let's find the time it took John. Time for John, J for John, equals the distance he traveled over the speed. Okay, it took him 51.28 seconds. Now it took Ali 2 seconds longer than that, so it took Ali 53.28 seconds. Okay, work out Ali's average speed. So we know his time and we know his distance, so yes, we can work out his average speed. So his average speed will be the distance he traveled. Now who is he? He's Ali, and we're calculating his speed. So his average speed would be 400 divided by how long it took him. Look, I can put in a few more numbers from up here. And now, so let's add 2 to that to make it this 53 seconds. And I'm going to do something weird. I'm going to divide by 400, which is upside down. And then I'm going to flip it upside down. There's a button for that. It's this one here. X to minus 1 means 1 over x. So I can just press that and look for my answer. And just to be sure, I'm going to do it the more standard way by just filling it in. But sometimes you can be a bit lazy about filling in, and that's okay. So, but let's make sure this makes sense. His speed was less than the speed of John. And it took him 2 seconds more, so that meets our expectations. And I also want to check for the precision accuracy level, so it's equal to 7.5, and the units are meters per second. You can write it that way, and that's our answer. Okay, now I did say I'd do this the other way. Just in terms of that, you just type that in again. 400 divided by, but it's extra work a bit maybe. 0.282. Okay, no matter what you do, you get 7.5 meters per second. As always, oh no, let's grade that and see what we're doing. Because you never know. Keep me on my toes, I might make a mistake. Okay, so the first two parts were lumped together. We got behind John with no explanation, correct? The distance was 25 kilometers and it was 1.5 minutes. So we got 10 out of 10 for that. Let's look any valid description. For example, Ali was passing John out or similar. Ali was overtaking John or similar, 10. Okay. Okay, so we've 34, 35, 36 and 105. Okay, and that took quite a bit of work, and I was willing to criticize myself and judge myself and correct it. So there was great problem solving here. This is a brilliant video. Very good modeling of what maths looks like, and perseverance and critical thinking and problem solving are everywhere here in this. Great question. Okay, and then finally we're looking for how many answers. Give your answer. I presume this is the final answer here, 7.5 meters per second. I forgot to talk about the precision, but anything in square brackets isn't actually necessary. But I should have said 1 decimal place, as I often do. Okay, we're giving ourselves 5 out of 5 for that, and as always, students, I will see you in the next one.